So, hi guys, it's me again, Iverson, and welcome to another edition of Allen Vlogs. So now, what are we going to do is, as you can see, we're here at Chapter 7, IP addressing, and we're gonna answer all the activities that are available here. So let's start. First, we are here at activities at Chapter 7.1.5, activity entitled binary to decimal conversion activity. So we have to do is this. We have to read the instructions first. So this activity allows you to practice 8-bit binary to decimal conversion as much as necessary. We recommend that you work with this tool until you are able to do the conversion without error. Convert the binary number shown in the octet to its decimal value. So here we can see the different numbers that are given, and this is the bit that we have to convert in binary. So let's start. So as you can see, it starts from 0 1 0 1 0 1 0 0. So when we are counting, when we have 0, wait, first, this position is equivalent to 128. This one is for 64. This one is for 32. This one is for 16, and this one is for 8. This one is for number 4, and this one is for 2, and this one is for 1. And when we are converting it to decimal, we will not include the 0. So it means the 128 here in this position will not be included, and we will include 64, and the 32 will not be included. We will include 16 because it has 1 here, and we will not include the 8, and we will include number 4, and the 2 and the 1 will not also be included. So 64 plus 16 plus 4 equals 84. So let's check. So it says correct, the decimal value you have entered is correct. Please click to continue. So we'll moving on to another activity. So we are now at chapter 7.1.1.8. It is entitled Decimal to Binary Convention Ident Activity. So I think the situation here is a little bit different than the previous activity. So instructions: this activity allows you to practice decimal conversion to 8-bit binary values. We recommend that you work with this tool until you are able to do the conversions without error. Convert the decimal number shown in the decimal value to its binary bits. So now we have to convert this decimal value to binary bits. So we'll include 1 or 0, and looking at the positions here, we have to refer her here um, for the value of the decimals of the binary. So now 48, so it is a very low number, so I think 32 and 16 will just be enough, because so we're gonna enter 1 for 32 and number 1 for 16, because 32 plus 16 is 48, and now the other places will just be 0, and our final bit or this binary bit is 0 0 1 1 0 0 0 0. So now let's check if we have entered the correct binary bits. So it says correct, the binary values have entered for all positions are correct. Please click new number to continue. We're done with this activity, and now we're going on to another activity in chapter 7.1.2.4 here. Also, what are we going to do is using the A and D process to determine the network address in binary and decimal format. So we have here the given host address, subnet mask, host address in library, subnet mask in library, and we have to convert it to binary and decimal. So first we have to convert it to binary. It will be 1 0 1 0 1 1 0 0. When it's just like a truth table. When we have 0, it basically equivalent to 0, and when we have all same number like all 1, we will write 1 here. So it will be 0 0 0 1 1 1 1 1, and it will be all 0 0 0 0 0 0 0 0 0, and I think the same as this last will be 0 0 0 0 0 0 0 and 0 as well. So now this binary address, we will have to convert it to 1 by 1 in decimal. So decimal number of this one is just like our in the previous activity, we will refer to the positions of here like 1 2 4 8 16 and so on. So this one we have to total 1 2 4 8 16 32 64 and 1 124. So 120. So this total, it has a total of 1722. So now this one is 1 2 4 8 16. 1 plus 2 plus 4 plus 8 plus 16 is 31. And this one is all 0. So obviously all 0, and as well as this one all 0. So let's check if we have entered the correct binary. It says the binary and decimal versions of the network address are correct. Please. Now let's move on to another activity. So we are here at activity chapter 7.1.3, unicast, broadcast, or multicast. So instructions: click start to view the destination IP address. Next, click the host, which will receive a packet based on the address type, unicast, broadcast, or multicast. This is a timed activity. So we have here the destination IP address and the source host. So the IP address will match here from the illustrations here, and this is the time, that the given time that we have to answer. So now we have here 192.168.100.5. So I think it is this one. So let's wait for the time. So you have successfully identified the transmission type. So we're done with this activity, and we have to move on to another activity in chapter 7.1.4.2, pass or block IPv4 address. So decide to pass or block each IP address depending on whether it is public, the internet, or private, the small local network. Click start to begin and click on either pass or block. So we have to click pass or block for the following IP address. So let's start. So pass. Start again. Block. Pass. 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 So I think we answered it all correctly. Says you have successfully identified public and private IP addresses. Now we will move on to another activity here at chapter 7.1.4.8, which is the public or private IPv4 address. I think it is somehow similar to a previous activity, but a little bit different. So we have to drag each IP address to the correct category, if whether it is public or private. So I think what I have noticed from the previous activity, when we have 172 and 192 start of IP address, it will be at public and also with 64. So I think the no no the also with, so it is for no, 172 is not included in public, it is for private, then 192 is for public, 192.0 is in private because only 192.168 for is allowed for public, then 64.104 is for public, 209.165.201.30 is for public, 192.168 is for private, and this one is for private also. Check. Incorrect. We have not correctly identified all the iPads. So I have one mistake, but it's okay. Oh, it is two mistakes, but it's okay. We will move on to another activity in chapter 7.2.1.3, which is IPv4 issues and solutions. So the description is, the instruction is drag the IPv4 and IPv6 terms to the field next to the appropriate description. So just like all the other activities that we have answered in previous chapters, it is drag and drop here. The description is already given here, and this is the space for the terms. So for number 1, 128-bit address or 340 undecillion addresses, it is for IPv6. 32-bit addresses and 4.3 billion addresses, it is for IPv4. Transports an IPv6 packet or IPv4 network, it is the tunneling. Uses NAT64 to convert between IPv6 and IPv4, it is for the translation, and allows IPv4 and IPv6 to coexist on the same network segment. So it is dual stack, obviously. Let's check. So it says you have successfully matched all the IPv4 and IPv6 terms to their descriptions. So now we will move on to another activity, second to the last activity. I think it's a little bit many. So what we have to do is convert the IPv6 address into short, omit the leading zeros, compress forms. Use the numbers at the bottom of the page to continue this activity. So here's the other activity. The continuation of the activity is here. The figures 1, 2, 3, 4, and 10. Then we will start at 1. So let's start with this. As you can see, is a given box here where we will enter the our conversion, and this is the IPv6. So 2001, when it is between these two number, we will include the 2001. When 0, we will only include 0. The 0 db8, so we will omit the 0 here. db8. Then 1 so we have to write 1 all the number here. So it's 0, and this one is 0 also. 0 0 0 also. This one is also 0. This one is 200. So we will write the compressed format for this conversion. We have to write 2001, then 8 colon, then db8, and then db8, and semicolon, db8. Okay, we have to put the 2 here. 0. So let's see if we have answered it correct. So let's check. So we have answered it all correct. So let's move on to another number. So it is, we have to enter 2013 0 123 400 4567 89 AB CDEF CDEF 0 and 1. So the compressed format is 2013 semicolon 0 semicolon 123 colon and 4567 colon 8. So 89 A B, then colon C D E F, then colon 0 and colon and lastly 1. So let's check. Did I did it wrong? 2013 0 123 here. So correct. We have answered this correctly, and now we'll move on to another number 3. So we only have this one here. So let's see, 0 0 0 0 0 0 0 0. So because it is all 0 and it is only, there is only one digit here, so we will just write two colons and then 1. So let's check. So it is correct. So let's move on to another number. Number 4. 2 says 2012 ABCD ABCD EF 01 2 3 4 5 6 7 and 8 9 1 0 4 A's and 4 B's. Then we will write the compressed format. 2012 colon ABCD colon EF 01 colon 2 3 4 5 colon 6 7 8 colon 910 colon and 2 3 4 1 2 3 4. Let's check. So it is also correct. And now let's move on to another number. So AB 1E 2P 00. Then we have 0 1 2 3 4 5 6 7 8 9 1 0 1 1 1 1 2 and then 1 1 1 3. So for the compressed format is AB 1E, then 2B 00, and then we have to put two quotation marks here for the 0. We will omit the 0. Then 1 2 3 4 colon and 5 5 6 7 8 colon the 90101 9101 then 101 1112 and lastly 1113. Let's check. So it's also correct. Let's move on to another number. So we have here BB 2B EF12 BFF3 9125 1111 101 1111 and 101. So the compressed format will be BB2B EF12 BFF3 9125 1111 101 1111 and 101. Let's check. So it is also correct. And now for number 7, we have 1129, 1984, 2233, 4455, 6677, and then 0, 0, and 101. So for the compressed format, it will be 1129, 1984, 2233, 4455, 6677, 77, 77. Then we will omit the 0, so we'll just add 2 colons here and then 101. So let's check. So it is also correct. So let's move on to number 8. We have 1111, 0, 0, 0, 0, 0, 101, and 1111. So for the compressed format, we have 1111, and now we have to add just 2 colons and then 101 and then colon and then 1111. Let's check. So it is correct. So let's move on to number 9. So 1031, 1976, 1, 2, 3, 4, 0, and lastly 101. So for the compressed format, it will be 1031, 1976, 1, 2, 3, 3, 4, then 0, 1, 101. So let's check. So it is also correct. And now let's move on to our last but not the least number 10. So we will have 0 here, another 0 here, another 0 here, and then 1, 2, 3, 4, 6, 6, 7, 8, 9, 1, 0, 1, 0, and 3, 4, 3, 4, A, B. So for the compressed version, we will just add 2 colons and then 1, 2, 3, 4, 6, 6, 7, 8, 7, 8, 9, 1, 0, 1, 0, 1, then the 2 colons and then 3, 4, AB. Oh, it is wrong. Let's just answer. So we have answered it all correct. So now we will move on to the last, I think it is the last activity for chapter 7. We are here at chapter 7.2.3.5. identify types of IPv6 addresses. So drag the IPv6 addresses type to the most appropriate description. So we have all the descriptions here. We have to drag these terms here for the appropriate description. So description number 1, the unique internet routable IPv6 address, dynamic or static. It is for global unicast. So this is the FE. I think it is for link local. So 2001 and DB8. So on is for global unicast. Then typical IPv6 prefix used to indicate the network portion of the address. It is the /64. And lastly, used to communicate with other devices on the same IPv6 subnet. So it is link local. So let's check. So you have successfully matched the IPv6 address types with their descriptions. So that's all for today's video in chapter 7 of this IP addressing. So watch out for the next video and thank you for watching.